Statistics, stem and leaf plots. Example 1. Construct stem and leaf plots from raw data using the following two sets of data. Set A, 17, 23, 27, and so on. And set B, the following numbers, 45, 37, 53, 61, etc. So we'll start with set A, 17, 23, 27. And if we look at the numbers, it appears that 14 might be the smallest number, and there are a few other numbers below 20. There's a 17 there, a 19. So it might be useful to start by considering the numbers between 10 and 19. Doing so, we get 17, 14, 19, and 18. They're the four numbers in set A in that range. So 17, 14, 19, and 18. And again, they're not arranged in any order, so we might usefully arrange them from the smallest, 14, to the largest, 14, 17, then 18, and then 19. So we've extracted the first four numbers here in the range 10 to 19. Considering the numbers now between 20 and 29, we use the same process. We see there's a 23 there, a 27, a 21, 25, 27, 25, 24, and 26. We write those numbers down. Once again, they're not arranged in order, so by rearranging them, 21 is the smallest number, and we had two 27s at the end. So now the numbers are arranged in order. We can represent the numbers in set A that lie between 10 and 29 as follows: 14, 17, 18, 19, as we got before. And if we complete the set for all of the numbers between 30 and 39 are 31, 32, and 35. They're there, 31, 32, and 35. And we've one number between 40 and 49, the 42. So there are values, we'll highlight them there. They're the values that we got when we put the numbers in order and also arrange them into categories. So using those numbers now to represent the data from set A in the form of a stem and leaf plot, we don't write 14, 17, and 18 because they all share the 1 in front for the 10. So we say 1, 4 for 14, 1, 7 for 17, 1, 8 for 18, and 1, 9 for 19, where 1, 4 represents 14. We do the same for the 30s, 31, 32, 35, and it saves us writing all the 3s. And 4, 2 is 42. We can get a sense of a shape here when we draw it in this form, that there are a lot more in the 20s than there are in the 10s, 30s, or 40s. It's bunched around here. Set B, another set of numbers, and we'll use exactly the same methods. The stem and leaf plot for set B turns out to be as follows. There's a 19 there, a 1, 9. There's a 71 at the end, and if we represent all the other numbers, we'll get this leaf plot here, where 71 represents 71. So again, we can see there's a shape here, a lot more in the 60s rather than in the set A that we had. Example 2. Represent the data for the two sets of data using a single stem and leaf plot. We're going to use the same data for set A and set B as before. For set B, this is what we got. We got 1, 9, 2, 3, and we had a graph like this, where 7, 1 represented 71. But to put the two graphs together, we share the 10 slot, because we had numbers in the 10s and the 20s and the 30s for set A as well. Now we can impose set A on top of it as well. So 1, 4 for 14, 1, 7 for 17, 1, 8 for 18. Now it's important to note that there's been a change to the layout for set A. Instead of the 1 coming first, it's coming second. So 4, 1 or 2, 4 doesn't represent 24, but rather 42. But you can see from the graph here that there's a very big tendency here on the lower values in the 20s for set A than for the set B. So, for example, if the two sets represent the ages of people attending particular concerts, we could see that the age profile of people attending set A indicates that the performer is of interest to younger people than this performer here, of more interest to older people.